Before melody, before any rhythm, before any instrument, there was only vibration. There was invisible movement traveling through space. A sound begins when something moves, for example, a string, air, metal, skin. That movement pushes the air around it, and the air begins to carry energy. To the human ear, this vibration becomes experience in the form of pitch, texture, emotion. But underneath all of it, music is still physics. No sound exists alone, every vibration creates a small vibration inside itself, in the form of layers, patterns, harmonics. These are all just a complexity emerging from simple motion. The moment when vibrations interact with each other, they start shaping each other in the form of amplifying, cancelling. But at its core, music is just a frequency, which is the speed of vibration itself. Welcome to second episode of Essence of Mathematics. Today we will discover the old relationship between music and mathematics. More than 2000 years ago, in ancient Greece, philosophers began studying something invisible, not matter, not light, but the sound. They noticed that certain combination of notes felt stable, balanced, and peaceful. The human ear already understood the harmony long before mathematics could explain it. Then came Pythagoras. To him, music was not merely an art, it was a mathematics made audible, a hidden order beneath the sound itself. Pythagoras experimented with the vibrating strings and they discovered something extraordinary. When one string vibrated exactly twice as fast as another, the two notes sounded deeply connected. This relationship became known as the octave, a frequency ratio of 2 to 1. It's different, somehow the same. It was not just the Greek that discovered the relationship between the music and the mathematics, but across the world, ancient Indian musicians were discovering the similar relationship. They were organizing sound into the structured notes. These are not numbers, but more like a structured notes in their own musical system. Different civilizations, separated by geography, arrived at the same realization. Harmony could be measured, and music contained numbers. Even after the discovery of the octave, there was another relationship that kept appearing in the music. The 3 vibration against 2, the perfect fifth. One of the most stable sound relationships humans ever discovered. These ratios sounded natural, as if the universe itself preferred them. Due to this relationship, musicians start stacking this relationship, trying to build an entire musical system from the perfect harmony. But there was something wrong. Every combination of the ratio musicians try, there was something unsettling feeling from hearing it. No matter how carefully the ratios was arranged, there was always a tiny bit of error. That tiny bit of error became known as the Pythagorean comma. Although mathematically that error was almost negligible, but our ears could feel it. This Pythagorean comma made us believe perfect harmony was mathematically impossible. Now, due to the tiny error, music needed a solution. A universal system that can combine every ratio into itself. The first method is the dividing the octave. So musicians made a compromise. Instead of preserving the perfect harmony, they divided the octave into 12 equal parts. None of the intervals would remain perfectly pure, but every key would become usable. For the first time, music could freely change the direction. It can modulate and it can travel. Now this division of the octave into 12 equal parts shaped the modern piano and eventually all other instruments, from the orchestra to synthesizer to digital production. The same system remained underneath. Every modern song inherits this compromise, a slightly imperfect system that allowed infinite creativity. Due to this system only, different instruments can tune with each other and produce a very good melody. Well, sound is not an object. It is pressure moving the air, compression, refraction, patterns of movement traveling towards the ear. Pitch is simply the speed and hence connected to the frequency. Slow vibration creates the low notes and faster vibration creates the higher one. Real sound that we hear in the real day life are never the single frequency. Every instrument contains layers, tiny harmonic fingerprints. This is timbre, the reason a piano and a violin sound different even when playing the same note. That is due to their harmonic fingerprints differs. Frequency can even shape the physical matter that cause geometry. Whenever a group of particles are exposed to a sound, they form certain geometry different to the different sounds and different frequency. Modern music transforms vibration into numbers through this certain process: encoding, sampling, and reconstruction. While encoding and sampling together means conversion of analog into digital signals, while the reconstruction means converting digital to analog at the end of the mic or speaker. And yet, whether the ancient or digital, music is still organized vibration. They all follow the same pattern, same ratios, same harmonic fingerprints of different instruments. But none of this explains why music feels emotional. Because emotion does not exist inside sound itself, the brain creates it. Your mind constantly predicts what comes next. And when those expectations break, we feel tension. When the pattern finally resolves, we feel relief. Music also attaches itself to memory for life moments, people, and loss. But the main part, music does not contain sadness or joy or fear or anything. The humans project motion onto the vibrations. We are emotional creatures, interpreting patterns in the air and finding the patterns in something that give us relief. Music is not magic, it is mathematics, physics, pattern recognition, and yet it still feels magical.